Okay, I was looking at Eleanor's slides for summer school. I must say again, Eleanor and Claire and Danny who are out there and have put huge amounts of effort into organising this. So I hope you're all going to make use of that. And as Eleanor said, networking. I did a PhD in pure mathematics. Automorphisms and coverings of Klein surfaces was my PhD, because I'm sure you're all aware that a Klein surface is the upper half plane factored out by a non-Euclidean crystallographic rule. Right. So in my thesis I worked out if Klein surfaces were topological by working out if the groups were isomorphic. It was as simple as that. And I practiced that. Anyway, and I went to the most amazing summer school in the second year of my PhD. Actually, my PhD, I shouldn't tell you all these stories, I've got tons of stories, I'm going to whiz through the slides, but in my PhD there were my PhD is 98, 99 pages, there's hardly any words, it's all algebra, and there are 19 references, and 4 of those were to the guy who was my external examiner. And it was a very small group, it was pure mathematics, so and I can't believe I've ended up in a field where you can have zillions of references and the field changes so dramatically all the time. When 2 years ago my PhD supervisor retired, so I graduated in 1977 with my PhD, and I gradually moved from pure maths to computer science via personal computers. So 1977 is nearly 40 years ago. And my PhD supervisor retired 2 years ago, and he said, "When do you know your third theorem? No one's ever rediscovered that. We could still publish it." And I said, "Well, I can't remember what it was about, and B, I haven't got the time." And he said, "I'll do it for you." So 2 years ago, we published a paper based on the last theorem in my thesis. And that's the speed at which pure mathematics work. Now I'm in this field, so that's a very pertinent story in terms of observing the web, because the web changes as I'm saying this sentence, it's changed, amazingly, significantly. And so observing it is a really hard thing to do. So I'm going to tell you the story of why we're trying to do that. So I'm going to have to whiz and stop telling you too many stories, because of course I have been around for longer than the web. So much down to Tim Berners-Lee, and I met him, so this, I'm sure you're aware, 25 years ago there's been a lot of publicity. This screen's awful. This is the paper he published, Information Management, a proposal in March 1989 about the web. Well, it wasn't called the web then, it was, and if you look at the paper on the web, you see it digitised. You've got HTTP, HTML, and we're going to use this thing called hypertext, and we're going to make links between documents, and the documents have been downloaded from the internet. And he pulled together the ideas of the decentralised nature of the internet, the use of markup languages, documents to create the hypertext links, so the networking ideas, the hypertext ideas, and the decentralised ideas of the internet, to think about how we could build a ubiquitous system for linking documents across the internet. He did it, of course, to help the physicists at CERN, where he was working there, share documents all around the world. And if you look, I can't see it here, but down in the right-hand corner, if you look at the document on the web, you see actually the semantic web. It's always part of his original vision. And his boss wrote at the top of the paper when he read it, "vague but exciting," which gave Tim the okay to carry on developing it as part of his job at CERN. So we went from, imagine what it was like. I first met Tim at the Hypertext conference in Paris in 1990. The next year, so the year after that, we were developing a system here called Microcosm, and we went and gave a paper there about it. And he was there with Robert Caillou. I haven't got the photos up, this is too much time. talking about this thing that was going to become the World Wide Web. And over the last 25 years, well, this is 2013, this is what's happened. And of course, at the beginning, so Tim put the first website up Christmas 1990. He called it the World Wide Web. And I remember thinking how pretentious to call it the World Wide Web. A bit like the World Series of Baseball. You know, it's just going to be something that physicists were going to use. And I remember looking at it and, like Ted Nelson saying, but the links only go one way. And they're embedded in the documents. You know, it's so limiting. And when you think about, so, you know, how it went from nothing, one website, and there's no web to go and download the code from, or you had to email Tim to get the spec for the protocols, and it all spread by word of mouth, really. And the fascinating thing, I mean, I can talk forever about this curve. It's, well, you can have these, well, I think what they're doing, you can have these slides, but there's the tipping points for how I remember, you know, when Tim and Robert were trying to get the European Commission to use, as it was then, this was around 94. So Tim stayed at CERN until 1994. And it was really the release of the Mosaic browser that made it take off, because it was a very simple click-and-go, read-only browser, whereas Tim's interface was both a browser and an editor, and it was quite complicated to use, and people just didn't get it. They didn't get the idea of hypertext, they didn't get the idea of a ubiquitous hypertext system, and they didn't understand why they would want to put their documents into this markup language that this, you know, crazy physicist from CERN was promoting. Who was he? It was just sheer dogged determination in many ways that got it over the barrier. But then the release of Mosaic, it was very interesting. Oh, so many stories. Because the people at NCSA, Mark Andreessen, also became famous for Netscape Navigator, released Mosaic and tried to persuade Tim to change the name of the web to Mosaic. And for a long time, Americans thought the web was Mosaic. And they were going to have a conference in Chicago in 1994, in October 1994. So Tim and Robert said, right, we're going to have the first World Wide Web conference. So they rushed to disseminate information, not on the web, of course, but by email and so on, about a conference at CERN in May 1994. And Robert actually underwrote the cost of the venue because CERN wouldn't do it, and they didn't know if anyone would show up. And actually they had to turn people away because word was beginning to spread because it was learning about this thing called the World Wide Web. And in the end they had to turn it away. And Tim's keynote, he talks about the semantic web as well as the web. And, but you know, most people were still thinking about what's a link and how do I get hold of the code. And so they had the first World Wide Web conference in Geneva in May, and then the second one was in October in Chicago. And it started to lift off then. The .com boom started, and this is what I'm talking to you about, is our Web Science Stories, really. This was looking at this graph that made us think about what Web Science was about, because Amazon starts, you see, in 95, and the boom started then, and investors, they all wanted to build Bill Gates, so they all piled into this internet application, these internet applications for selling things on the internet. But when you look at the technology curves, we don't see Wi-Fi and broadband until the turn of the millennium, such a wonderful phrase, the turn of the century. 10 years after the web. Lots of you will not remember these times, but before Wi-Fi and broadband at home, you had to use a modem to dial up, and it was very long, and then it would all crash and time out if you tried to download a picture. We used to call it the World Wide Wait. And you know, there was no way anyone, you couldn't possibly think about, nobody had computers at home, there was no point in buying them, there's nothing really you could do with them except play games. And, you know, there was no sort of concept of anyone being able to put up a decent catalogue. You could talk about the future, but it just wasn't there. So of course that boom had to burst, bubble had to burst, because the companies were way overvalued for what they could deliver. And I remember reading one of the broadsheets when the bubble burst. Lots of people lost a lot of money, of course, and one of the journalists I can't remember, I think it was the US, on the broadsheet saying, well, that's the end, that's categorically the end of internet shopping. Right, we have now proved that people don't want to shop on the internet. I haven't proved anything of the sort. but that was, you know, oh, that's it. We're never going to have. And now, of course, we're looking at a world 20 years later, well, not less than that, where we've got trouble with the, you know, the shops on the high street are dying, because the shift now is we have reached the tipping point where more and more people are doing more and more shopping on the internet, and society's got to tackle the issues of what it does with the high street. But that's one of the stories in there. The other one, of course, is Google. Most people assume that Google and the web have been around for the same length of time. Google actually, Brin and Page published their paper with the PageRank algorithm about how they were proposing to do search on the web in the web conference in 1990. I always forget if it was 7 or 8. I think it was 7. I think it was the one in Brisbane. Everyone said, oh, great idea, you know, it'll never work, it'll never scale. So they borrowed money, and you read the story, nearly went bust several times, used Stanford PhDs, they were Stanford PhDs, of course, used friends to do the coding, and proved that they could make it work. They did the engineering to show that it would scale, which is an amazing concept in itself. If you think about searching the whole, you know, searching for indexing, really, the whole of the web at the rate at which it now grows, let alone it was a bit less then. Fair enough. And then, of course, they had to come up with making a business out of it. And the thing about the web is that the way Tim designed it, his real legacy for the world is that he gave it away. He came up with the ideas. There could have been other ways to do it, technically, lots of different ways. But his ways scaled. Okay, so that's one thing. But the other thing is that he gave it away. And if I mean, this is a web science question. You can write an essay as an answer. Should you be, you know, what would it, if Tim had been a Bill Gates, if he'd been an entrepreneur and sold the web, what would have happened? How would it have turned? What, you know, do the mind games of how the world might have been different. It's a very interesting question to ask as it drifts into that scenario now. It's a very, very potentially scary turning point for the world. Could go either way. Could go many different ways, but we're now looking at a world where, because this thing has become so dominant, governments and big companies are looking to own it. And of course Tim and others are fighting that, but we want this thing to keep going forever. You know, in 100 years' time, in 500 years' time, we want people to look back at what we did now and say, hi Sophie, say, they did a good thing for us because they set this ecosystem up in a way that it would carry on into the future. Can it always be of the people? Can it always be free? Can it always be open? These are the questions we're looking at now, which is, this is sort of like my last slide, and I haven't got past slide 2 yet, but it's like, this is why web science is so important. Because we need to think about making this fit for purpose going forward, so it will last forever and not just be of the moment and revert to something that's owned by one of the big companies or overly regulated by governments. It's so new, it's just out of diapers, as the Americans would say. No, I think it's a bit more grown up than that now. It's probably through adolescence, but So the point I was going to make was because Tim gave it away, one of the effects of that was people used it very quickly because it was free and open. Anybody could pick up the code, set up a website, pull that, get a browser, start looking at it. No barriers, technically or financially. But the downside, the consequence of that are, one, nobody owns it. So we're now struggling with how do we regulate it, who's going to own it going forward. But the other thing is, by the nature, it builds because of the network effect, right? As you do things on the web, you put content on the web because there's a chance anyone in the world could read it. So you get a return on investment of your time. And I mean, we were building hypermedia systems before the web, and boy, we just couldn't get people to author hypermedia. We struggled. I've got people at the back of the room there who remember trying to make this happen at the university. We had to pay people to author hypermedia because it was really very difficult. They had to create the content and then put the links in. And they would say, why am I doing this so a class of 20 people can read it? Of course, you do it on the web because potentially the whole world, the whole of the people on the internet, all the people on the internet can read it. You get that return on investment. But the other consequence of this, because it's free, it's all based on the network effect, is that when a company, so like Google, I should put Wikipedia on here, one of my PhD students who is graduating on Wednesday does this graph for me, and he's still doing it at the moment, but he doesn't need a PhD anymore, so I have to work out what the how am I going to persuade him in the future to keep this graph up to date? Anyway, put Wikipedia on, but you see Facebook, and he started to put Twitter on. Or have I got the old graph here? No, Twitter uses, yeah, this is Twitter. Is that because it's all based on the network effect, once you persuaded people to join your social network, more and more people pile in, and then they become, in mathematical terms, giant attractors. It's like black holes or centers of gravity, and it's really difficult to start another one. Because you don't want to be in the social network where your friends aren't, right? You go where everybody is. That's the nature of the beast. So we get these effectively monopolies. And then you go to China, you get another different set of monopolies. You get Baidu and Weibo and Tencent, but you get the same type of monopolies, right? You get, it's like, where do you go for your photos? Where do you go for your videos? All these things, the YouTubes, Flickr, that have been bought up by the big commercial companies. When they become successful, they have to be gobbled up because they're threats, and the companies want that technology. So this is the nature of the beast. You get these huge, great attractors, and this is another part of observing the web, is seeing who's eating who on the web, right? And where the people are moving to. And it's a bit like, I'm going to come to this in about 20 minutes, it's a bit like the astronomers looking at the stars, you know? What big companies are eating up what little companies, where are the people going? Are people, I mean, the youngsters today, where are they, what social networks are they using? Because we're sure they won't use the same ones their parents use, all those sorts of questions. The other thing is the three phases. It started off as read-only, and Tim said people won't use the web if they can't write to it. And in fact, it was more than that. It was his insight was that it is people writing to it that will make it grow. And it isn't, he didn't create the web, we all create it, he invented it, but he didn't create it, we create it because we put stuff on it, and that's what makes it grow. And the social scientists will say we co-create, we co-constitute. It's a socio-technical activity. That's really the essence of web science. But when it started off, it was good enough at the beginning just to read, because that was amazing. There were things to help you read other people's documents on the internet. Before the web, there was Gopher and there was WACE, which we named our research group after. In fact, Gopher was becoming very popular in the 1990s, and then where it came from Minnesota said, oh, we're going to start charging for this. And so Gopher they were going to charge for Gopher, and the web comes along and it's free. So everyone looks at the web. And Gopher was no more, except in the Computer History Museum in California, where our microcosm system is as well. These are all bits of history. Will the web be a bit of history one day? That's the question. So as the browsers evolved and enabled us to write without having to be able to code, so the blogs emerged, the web blogs, the blogs, and people started to write. That's when it really started to lift off. And then we got this amazing social web emerging as more and more people started communicating with their friends and so on, and family, and all these things started to emerge. The death of MySpace, the rise of Facebook, all those stories that scientists or what does Ted want to call it? It's web historians, but there's a nice phrase about web scientists who are also historians. I can't remember what it was. It was all, by the way, in the trilogy Foundations of Empire. It's all in there. You read that, if you know the Asimov trilogy, it's all in there. All what's going on here. The psychohistorians is what we wanted to call web science, psychohistory, but we didn't think anyone would understand. We also wanted to call it philosophical engineering, because Tim studied physics at Oxford, where it's called natural philosophy. And he said, no, this is philosophical engineering. But we didn't think people would understand that, so we called it web science. And people don't understand that either, because they think it's very technical, or it's all just about this little thing called the web. Anyway, one of the most amazing stories, and one that I'll talk a little bit about this one, and then quickly go on a bit more to the future. This is where I live, here in Hampshire. West Wellow, or Wellow, has an east and a west, either side of a Wellow, which is the Anglo-Saxon for valley. And it was in the Domesday Book in 1076, or whenever the Domesday Book was published. And now here we are in Wikipedia. Isn't that exciting? It's still a tiny little village. Well, it's a bit of a commuter village. It's got a modern housing estate and so on. But so this, and my husband was chair of the village council. That sounds grand, doesn't it? It's called the parish council in the UK. And he wanted to spend some money on the village's website, and the council voted against it. This was only 2 years ago. They voted against it because they thought it was a waste of public money. Anyway, so when I gave a talk I gave the parish council talk at the village hall last year. Hundreds of people came, and I showed them that, in fact, despite voting against a website, they're on here because someone's created a Wikipedia page. So, yahoo, sucks to you. Anyway. It's just amazing that this ecosystem has emerged from an idea that Jimmy Wales and his colleague, his name had 10 years ago now, really, 8, 9, 10 years ago. When did it start? 2000? Look it up. Someone look it up. When did Wikipedia start? Anyway, where are we? 14. I think it was 2006. It was 8 years ago. Anyway, someone come up with the answer. Ramin, you're looking, aren't you? And everyone said it wouldn't work. Including Jimmy Wales wasn't that sure it was going to work either. The idea that we always knew there'd be encyclopedias on the web, and of course you can look at the Encyclopedia Britannica on the web. But the idea that we'd have an encyclopedia created by people who weren't professional encyclopedia creators, and that it would be governed by the people. When's it? Were you there?
2001.
Was it? Yeah. Oh, so it's 13 years old. It was less than that. No, okay. It was dismissed as rubbish when it started because there's nothing on it. And now we've gone to the point where everything's on it. There's all these issues about the governance of Wikipedia. In fact, the number of authors, the number of people that contribute to Wikipedia is going down because they feel that it's over-governed, and some of the things they're writing are rejected. We had an amazing example of that Last month we launched a new Web Science Institute, so all the activities we're doing at Southampton, we launched this umbrella activity called the Web Science Institute, under which this summer school is being run. We had a big event in London at the Royal Society, did the launch, and one of the people in the audience, who's a registered Wikipedia contributor, created on the fly a Web Science Institute entry in Wikipedia. So I'm there, Tim's there, Nigel's there was a whole string, Susan Howard was there, we had external speakers, blessing this event, and the editors of Wikipedia rejected the Web Science Institute page as being not important enough or not significant enough. And you get this all the time, people try and put an entry in for somebody and it gets rejected. And so there's an interesting way about which it's being regulated now. And I don't know what the threshold, how many authors do you need to keep Wikipedia going? What's the level? If that level drips off too much, is Wikipedia going to start getting stale? What does that mean? We need all the data about how many entries are going in every day, how many people are writing, how many people are reading. We need that data in order to analyse the health of Wikipedia. And we don't know the metrics by which that can be judged yet. And that's a web science question. Because the world at the moment just hopes Wikipedia will keep going. Because the industry that used to publish the encyclopedias we used to read has stopped. We still have Encyclopaedia Britannica, you can pay for it and look at it on the web. But if, there's no printed version of it, and what we rely on with Wikipedia is its constant growth. It's of the moment and more accurate than many of the old encyclopedias because people can correct. So there's a whole sort of how do we keep this thing going, and there's also, of course, they're always struggling for money. Can it stay as a charitable venture, an of the people venture? I'm just talking, so the estimate in Wikipedia is that if you printed it out, it would be nearly 2,000 volumes, equivalent of the Encyclopaedia Britannica. The last printed version of Encyclopaedia Britannica was 37 volumes. And it's estimated if you print Wikipedia out, it would be nearly 2,000 volumes. I don't know if any of you had in your houses Encyclopaedia Britannica or the equivalent in your country or culture. It was a very expensive thing to buy to have printed out. We used to have a dictionary and we used to have the Pears Encyclopedia in the UK, which started printing in the Victorian times, I think. We used to get that every year. There's this, when I was a child, when you went to the doctor, you had absolutely no idea what was wrong with you, because you had no way of looking up anything. We used to have this Pears Encyclopedia that was, it was just about this big, so it told you it told you had a heart and a brain, and there might be things wrong with them. That was about it. Blood went around the system and that sort of stuff. Nowadays, of course, there's this whole debate about, firstly, you have a completely different conversation with your doctor because you go and say, I think I've got this, rather than these are my symptoms. And also, there's this huge cult of hypochondria. People terrified that they look something up, they've got a sore throat, okay, I've got lung cancer, and all that sort of stuff. And very different way that our relationship with our doctor is very different. Right, I'm on slide 4 and I've got 56 to go, so I better clean up. So, I could tell the story of Twitter, but I haven't got time, and YouTube. Right, let's just pick up on, start looking at the data, because we decided to focus this summer school on the data science, the web science, if you like. And just to make the point that although as I made Tim's original proposal had the idea of linking data, the semantic web, as well as linking documents in it, that was far too complicated to get going to start with, and so linking documents was hard enough to get people to understand. So he had to sort of park that idea, even though it was part of his vision. And in the in his book that he wrote in 1999, Weaving the Web, and in the conferences after that time, he started talking very much about the need for linking data to achieve the full potential of the web. The idea being, of course, that we have the search engines to help, and we have the links. Google and the web are, of course, completely synergistic. You need a Google for the web, and the Google can't exist without a web because it works on the link. So, but that when the machines have done search and looked at the big inverted matrix and said these are the ones that are most important for your, they're likely to be the most important for your search. You then decide which document to look at, because the machines can't really understand what those documents are about. They can say this is likely to be the relevant one. So we pick the documents we're going to look at. The idea of the linked data is that the machines, if you describe the data in some sort of ontology, and this got the world all very bogged down in ontologies and AI for a while, but if you just give some context to that data, some schema, the machines then can actually do inference across linked data in a way they can't do, because they can link across different data sets and use the vocabularies, the ontologies, to actually say, well, this is the one. It's more intelligent search. This is the data that you need, and here's the answer to your question. We've gone there. This is the standard stack Tim produced, structured documents, a way of linking the data, or publishing the data so you could link it. The resource description framework, define triples. A way to define ontologies, which is way overcomplicated what we need to start with. Keep them simple, keep them simple is the message. But if the machines are giving you an answer to a question rather than pointing you to some documents, then for sure you need to know where that data's come from, so issues of trust and provenance are really important. Anyway, about in 2004, so 10 years ago, we were at a web conference in New York, and Tim came out with the Southampton crowd for dinner and was worried why the semantic web wasn't, why aren't people using this web of linked data? And to cut a very long story short, with Nigel Chappell and Danny Weitzer, a colleague of Tim's, we started talking about looking at that graph, looking back at how the web had grown, and thinking, well, why are people not using linked data? One reason, of course, it's much more complicated technically to do, but they also didn't see the reason. It was the same as the first web. Why have I got to put my data in this format? What's the benefit to me of publishing that data and so that people can link? It was exactly the same as people said 10 years earlier. What's the advantage to me to publish my documents in these formats so that other people, I can link to and from other documents and people can link to mine? What's the advantage? And you can't see the advantage until there's the network effect. You get the return on your investment. So two things happened. One, with Nigel and Tim published this paper about simplifying it all down to very simple principles. This is the IEEE paper published in 2006, Semantic Web Revisited, saying actually it's just as simple as the first web really. Don't worry about too many ontologies, use the simple standards, use the HTTP, put your data in a form so you can A, publish it, most importantly, B, if you RDF's easiest to do the linking across different data sets, and link it. And then Tim came up with his 5 levels of linking or publishing data, and so that was one thing that was happening around that time, and we've since then emerged into this world of big data. Jim calls it broad data, linked data, open data. And of course the open data movement was actually part of Tim saying, I'm going to try and persuade people, starting with governments, to make data available. Once we get the data out there, then we can see the value of linking it. So it was a means to an end. The open data movement initially was a means to an end, the end being the semantic web. But actually it's become an end in itself in a way, as well as being a means to an end, because people are beginning to see the benefits of open data for open innovation, and Nigel's going to talk about that on tomorrow, and Jim Hendler will talk tomorrow. Is Jim talking tomorrow? Jim and Nigel tomorrow. I don't know what Jim's going to talk about particularly, but Nigel will talk about open data and open innovation. So that's so the web and the internet are both, they've done two things. One, they enable the generation of lots of data, so we've got this big data, and they also enable the analytics of it, and you need the analytics of it in order to do the innovation around it, so it's both ways around. So when we were thinking about why the semantic web wasn't working, we actually started, as I say, analysing how the web evolved, and so we started to think we've got this amazing complex system that we've built that we just don't understand. What are the characteristics of it? What drives it? How do things grow? How do they die? What are the sort of, the things I've started to say? What are the? How do you measure the health of Wikipedia? That sort of thing. But our argument was this is so fundamentally important to the world that it's important to look after this ecosystem as it is the ecosystem of the physical planet. So our argument is the health of the digital planet is as important as the health of the physical planet. And that you can't do it from a computer science or a social science or a legal or an economic background. You need to bring all those things together in order to study it. And this idea that it's very socio-technical. You can't just study it from a computer science aspect separately from a social science aspect or all the other sciences that impinge. So in 2006, I should change this slide, it's getting a bit dated. We launched a Web Science Research Initiative joint between Southampton and MIT, and that's Rob Brooks, who was head of CSAIL at the time, Tim, myself, Danny and Nigel. We got a lovely quote from Irish Schmidt of Google, not any money, but we got a quote. And the story rolled around the world, and it was a bit like jumping off a cliff and without any wings and deciding if anyone would follow. And we spent 3 years sort of evangelising what we meant by the idea, and then we launched the Web Science Trust in 2009 as a not-for-profit, and all the other things that have resulted. This was the butterfly diagram that sort of describes how all these, we need to think about it from all these different perspectives, but you don't have to understand, you don't have to be an expert in all these different things in order to understand the web, but you need to think of it from an interdisciplinary point of view, so it's more than the intersection. There are lots of subjects, people say, where's philosophy, where's education? Lots of subjects should be on here. But it's those, and for our web science degree here at Southampton, we allow people can come in with any different background really, as long as they can show that this is what the world they want to do. Right, I need to get on to observing the web, because I've got, can I have 45 minutes? Can I have another 10 minutes? Because I didn't start top of time. So, she's sort of saying, she's a very tough taskmaster, Eleanor. Right, so we've got labs all around the world, and we have our institute here at Southampton, that building over there, on the other side of the road, that's what it looks like at night. It's very pretty. A lot of electricity it uses though. This is a group of students last year, a very entry cohort for our PhD program last year, very diverse bunch of people, both in terms of gender, so I see a nice gender split here today as well, and in terms of their backgrounds, all from different disciplines. We've got a MOOC, I don't know if you looked at that before you came, probably not available at the moment, it will be relaunched next year. We've done it twice now. Something that we have talked about a lot at Southampton. I'm going to have to skip some of these slides and not go into too much detail. We have a big programme on social machines, the web as a social machine, and this is very much the concept that Tim talked about in his book. The idea that we were beginning to pick up on when we launched Web Science was that Tim didn't create the web, he invented it, but we all created it. It's co-constituted by technologists, by machines, and by society. And Tim, in his book Weaving the Web, talked about the theory and practice of social machines. Oh, sorry, no, it's our phrase, the theory and practice of social machines. He talked about this new idea called the social machine. So this was 1999, he wrote this, or Mark Fischetti wrote it with him. And in the middle of that it says, computers help if we can use them to create abstract social machines on the web, processes in which people do the creativity and machines do the administration. this concept of a social machine is not like a traditional machine. It's the idea of people and machines working together. So you've got a system of people, which is a society of people. You've got so it's two systems coming together: people and technology, machines, doing things together, not necessarily aware of what they're doing, but creating something that couldn't have existed without one or the other of those systems. So Wikipedia, or Facebook, or Twitter, or the web itself, or Google, or TripAdvisor, or Amazon, or eBay, they're all examples of social machines. And this is Dave DeRoy slide that we use quite a lot. More computers, you get more data, and more people, you get more social networking. When the two come together, you get this social machine. And we have a grant here, Southampton with Oxford and Edinburgh, which is talking about the theory and practice of social machines. And a key thing, go on, go. What? Oh God, they're all going down. What time? Is there coffee after this?
Yes.
Right.
In the room next door.
Right, I'll talk for another 5 minutes, then I'll finish the session myself. So, right, so a big thing that we sort of, I really feel quite strongly about is that, because I now understand that, I've obviously been a computer scientist. Well, I say obviously. When I moved from pure maths, I went into computer science, actually did a degree of MSc into computer science, so I became a legitimate computer scientist. And that's all about Turing machines. It's all about what you can do with the things Turing defined. And the social machine, if it could be done by Turing machines, it's not a social machine. It's the basic argument, right? Social machines are not Turing machines. So the argument is really that the web couldn't have been created just by someone writing a program. Right? That's quite important to get. Okay, unless you go by the idea that if you have an infinite number of monkeys, they'll eventually produce the Bible, that sort of argument. But it's even more complicated than the Bible, or the works of Shakespeare, or that's what the monkeys usually create. Anyway, whatever it is, it's more complicated than that. So I sort of say, well, now if web science is the theory and practice of social machines, then computer science is the theory and practice of Turing machines. And so I'm now coming to this idea of observing the web. I'm just going to talk to you for 5 minutes about observing the web, and you're going to, Ramin, who just went to do something, is going to be giving you tutorials on this concept of the Web Observatory. And I'm sorry this is far too much for you to read, but when we were thinking about how we study social machines, we were thinking about the need to observe their growth and their decay, and how many people are using them, and people moving from one to another, and how they become interlinked, and is there a classification of social machines, and what is the theory of these things, and how do they work in practice? This is all about trying to make sure this ecosystem we've developed will be fit for purpose for many hundreds or thousands of years in the future. It's also very new at the moment, and it's very hard to think about what that might be like. So when the historians of 100 years' time look back, or 500 years' time look back, what are they going to be looking back using? So we came up with this idea of thinking about observing the web in the way that, so there's an IEEE paper that Glasses Tirapanis from here, myself, Nigel, Dave DeRoy, and Offshore Contractor Jim Hendler wrote last year, May 2013, about the Web Science Observatory. It was our very first sort of excursion into this idea. And again, you always think, it's like when we launched Web Science and jumped off a cliff without wings, you think, well, is this a stupid idea? Are people going to say it's stupid, or going to say, what a wonderful idea, let's do it? And actually, you do get a mix of both. you often get it's a stupid idea from people who don't understand what you're talking about, and that's often because you don't explain it very well, because you don't know what you're trying to do yet. And other people get it immediately and sometimes get it faster, go faster and further than you do. So, but it was the analogy with how the physicists observe the stars so that we can understand the universe, and they take all their pictures, they build these telescopes which are very expensive, and they put them in beautiful places around the world because that's where there's no interference. They take all the pictures and they download them and then they share them and analyse them. And they have a way of doing that collaboratively, so we get this pattern across the heavens. And another group of people do it with the climate scientists, environmental scientists. You know, you can't understand what's happened to the climate without capturing globally the metrics, the measurements, the temperatures, the wind speeds, the currents, what's happened to the glaciers, the oceans. And we all know the fuss there's been about data sets for those platforms. And it costs a lot of money to send a boat out into the ocean and gather data. So there's an issue about sharing it. But so it's that idea that we could observe the web by building our own types of telescopes, which of course would be software. And so it's really a global movement that we're trying to get going, which is that just like you have amateur meteorologists all around the world measuring the temperature of their back garden and sending it in to saying, here, this is what the temperature was in the back of my igloo today, or whatever, to having people on the digital planet measuring, recording, reporting what's going on, and the big labs being a repository for that information, collecting their own information themselves and sharing the way they analyse it. So this is a slide that NASA's produced. This is us building, we want to build our own software telescopes to observe what's happening on the digital planet. It is a mega idea when you really think it through, absolutely mega. And I hope it's something that you're going to explore here in this summer school today. So I haven't got time to go through the detail. It is about sharing data sets and sharing ways of analysing those data sets. And you're going to get a whole tutorial on this as part of this week as one of the data science aspects of web science. So I don't need to go into too much detail. Ramin will take you through. One of the things I will point out, though, is that it won't all be open data we're looking at. This is one of the key things we want to get across, is that some of the data we need to look at is either very secure because it's commercially in confidence, or because it's about people, there's privacy angles, or it's to do with governments that they don't want to make open because it's too secure. And we need to create safe havens for people to do this analysis without the threat that all the raw data is going to be published, so that private data or secure data, commercially confident data, isn't put out accidentally to the world in cataclysmic ways. So one of the things about the architecture is a distributed one and one that allows different levels of sharing. But the idea would be that you publish the results of what you've done in terms of the derived data or the statistical evidence you get from that data, even if you can't publish the data set. And you can tell people where the data set is and reference it, even if you can't publish that data set. So, this is a Dave DeRoy slide. He tweeted this photograph of a PowerPoint slide. The other thing is, it's really important, I think, in our world that we can do repeatable and reusable and all those R's, reproducible, replicable experiments. Because at the moment we have people all around the world gathering data or working with companies and analysing data, and they do the work, they publish the paper, and then it all just evaporates. And it's really hard for people to repeat those experiments, to test that experiment in their culture or with their company or in their context. And I think that's really bad science for us, right? Because we publish make lots of claims and nobody can check them. I think it's really bad science. But actually what we're doing is building a social machine to observe social machines, because the only way this will work is if everybody does it. Right? So we've got the same problem you have with the web and the social networks, is at the moment it's a very embryonic activity. We have an observatory here, and Jim has one at RPI, but very few people know about them yet. And we want these to exist all over the world. All right, so I hope that when you go back to your laboratories and your universities and institutions, you'll think about becoming an observatory for web science. So there's two, it's not just, so we need big institutions, big companies, big labs will be able to build their own. So it's really, let me just explain the architecture of one. Here's our one at Southampton. There's lots of different ways of building our telescopes, our observatories. Or actually Ted says we should call them web observatories. We should come up with a new name, Ted Nelson says. But I like the analogy with a telescope. These things will be quite hard to build because they're data repositories. You need to be able to run the Hadoops and things on them. You need to be able to run the analytical tools. But then the idea is people can, just like when the physicists bring their photographs down and say, you can look at these photographs, you haven't got your own telescope, you can look at the photographs we got with our telescope. That's what we want to do with the web observatories, is to say to people, here, you can run your experiments on this data. Right? You might not be able to be a big data repository, an analytics engine, but you can use one. So it's a big collaborative sharing effort as well as actually building the environment to make this work. So we're building one at Southampton. It's got to be distributed, and you've got all the problems about distributed querying and so on in databases. Ramin will go through this with you when you have your tutorial, so you don't need to worry about this now. Allow for all different types of ways of analysing data, harvesting data from the web or getting data sets from companies, and then bringing it all together and doing the analytics and then sharing the analytics. So there's, if you like, this is the storage of the data sets and the analytical tools. Of course, they have to interact with each other, is the telescope, and you then portals onto that will be the way that the community can use it or look at it. And then the idea is you link all these up. So you have different instances of data, of data repositories, and you link them up as well using linked data. I'm going to skip through this because you haven't got time to look at it really. So it's not just about technology though, it's about people. We will need to build these repositories, but it's about curating the data sets as well. Huge librarian effort here, or whatever you want the modern version of the librarian to be, and sharing the analytical tools. So it's all about linking up, and at the moment we have an observatory here, and one at RPI with Jim, and there's the INS one for NASA setting up as an Internet Observatory, Internet Science Observatory. There's one in Bangalore we've just set up, and one at that's in California, UCI. So, and if you want to write this down, you, as I say, you will have a tutorial on this. This is the URL, so it's ecs.socm.ac.uk, it's web/001, unless they've changed it since I last looked at it. And if you look in there, I won't do it now because we're running out of time, but you see analytics of projects we've done. This is a project that our students did with our colleagues, students in China, looking at, this was a project, it was after the Fukushima accident, all the radiation, the Chinese were worried about the radiation getting to them, and there was an idea going around that salt protected you from radiation, and so they ran out of salt in all the supermarkets in China. And so we got the data sets about this. I don't know how they got them or where they got them from, Ramin will know. And then the social scientists started looking at the social networks and when people started making jokes about this. And the argument being that when people started making jokes, the crisis was over, or it was getting so black that they were making black jokes. So there was an analysis of the humour around that incident. Comparing Twitter and Wikipedia is another one. I've done 50 minutes, sorry Eleanor, but this is, the important thing is, I'm nearly at the end now, if you're going to become an observatory, then you need to tell people that you are one, and you need to tell people what data sets you've got. And so Jim may talk about this on tomorrow. At RPI, they've been developing a schema.org, which is a way of doing linked data that's accepted by the Microsoft and Googles of this world. And then you can publish your data sets according to this schema, which is on the web, and tell people that you're an observatory and what data sets you've got in your observatory. And that's, again, I'm sure Rameen will point you to this in the tutorial. This is where the definitions are. There's one on the W3C. They're on the W3C site. So that's the grand plan. And as I said, the reason why we're doing all this is because we have to think about, we've had 25 years of the web, and I can go back to these, I'll put them back at the end, but this is the last slide, we are at quite a big turning point at the moment. The web's just turned 25, it's amazing what it's done, but there's all sorts of major challenges going ahead. Who owns it? Who governs it? The issues of cybersecurity, privacy, trust, net neutrality. Who has the rights to do what with our data? Last week was quite an amazing week. The UN published for the first time a big report on what governments should think about when they're playing fast and loose with laws about data. In the UK, a week ago, our Prime Minister stood up and said, I'm rushing an emergency law through that says the companies, the ISPs, have got to store all your emails and texts so that we can look at them if we want to. Who gave them permission to do that? I didn't vote for that. They're doing it for the security of the nation, but what rights do we have as individuals in this? You know, they have to get a warrant, a search warrant, to come into my house, but they clearly don't have to have a search warrant to look at my data. Is that fair? You know, and and there's a UN report published last week, just last Thursday or Friday, quite a long one. Really important, really important report saying, yeah, you need to protect your citizens and your nations from the people that seek to do us harm, but actually we all have rights within this, and governments have got to look at this. This is there are no rights and wrongs. We've got to work this out as a society. And that's why web science and the data of web science is such an important topic. And that's why observing the web is such an important topic. I'm going to stop there so you can go and have a break, a coffee, and see you all later.